Well, welcome Greif Higher pupils to the next video in the higher straight line. Once again, if you can work through using the notes provided in Show My Homework, or alternatively copy through the examples along with the video. So 2 new bits of content today. We have the distance formula and we have parallel and perpendicular lines. So the distance formula is kind of self-explanatory in the sense it's the distance between 2 points. And within that, there's a direct relation to Pythagoras. And I'll show you that when we look at our first example. So in the example, we'll calculate the distance between the points E and F. If we were to plot those points within a coordinate diagram, very, very quickly, we have the point E, we have the point F, and we are looking for the distance of those 2 points. So if we looked at that a wee bit closer, if we formed a right angled triangle, our distance EF is hypotenuse, and we would square the horizontal distance, would square the vertical distance, and square root to get our hypotenuse. The horizontal distance is simply taking the 2 x coordinates and subtracting one from the other, and the vertical is doing the same with the y. So linking that back to our distance formula, we can see the clear link with Pythagoras. In our example, calculate the distance between the points. Our distance, in this case EF, is the distance between our x's, distance between our y's, and again making sure we're being nice and accurate, x and y of our first, and x and y of our second point. So substituting in, 2 minus minus 2, and minus 4 minus minus 1, and both of them are squared. So we have 4 squared, and we have minus 4 plus 1 would be minus 3 squared. 16 plus 9, root of 25, so therefore the distance between the 2 points EF would be 5. For some examples to work through, again, these are detailed within the PowerPoint. Second bit of information today is parallel and perpendicular lines. Parallel lines is something that you have met before, that 2 lines with the same gradient are said to be parallel. So if you had the gradient of AB, that would equal to the gradient of CD. Our new content today is 2 lines are said to be perpendicular. If a line of gradient N has a perpendicular gradient, and we have an M with an upside down T to notify a perpendicular. Okay, and this fact here, if we take our line and we multiply by the gradient of the perpendicular line, we would get a value of -1, and this would happen every single time. Okay, the other way to look at it is if we had that detail, then we can therefore state that the lines must be perpendicular. So it works in both ways. Okay, what we'd be looking to do most of the time is to be able to work out a perpendicular gradient. Okay, the perpendicular gradient of a line is the negative of the reciprocal. If you've not met the word reciprocal before, a wee bit of detail in this right hand side. So we had a fraction AB, the reciprocal would be the two values inverted, so we would have B over A. So if we had a negative reciprocal, we would have our gradient of 2, 5, for example, and our perpendicular gradient would be the 5 becoming the numerator, the 2 becoming the denominator, and making it negative. And that would be our perpendicular gradient. If we have a value that is not a fraction, then we can think of it as a fraction in the sense it would be not minus 3, but minus 3 over 1. And then that would be flipped and made negative as 1 over 3, and it would therefore become a positive value. Okay? When you're working out a perpendicular gradient, it's vital to give yourself the reason behind the working that you're doing. Okay? And that's simply by stating the wee statement at the end, m times m perpendicular is equal to minus 1. So, few examples that we can take. So for each of these, we want the parallel and perpendicular gradient of our line. Okay, so for A, if we have y equals 2x plus 3, the gradient of that line and anything parallel to it would be 2 from y equals mx plus c. And as m times m perpendicular is equal to minus 1, m perpendicular in this instance must be 2 over 1 flipped and made negative. So the perpendicular gradient of 2 is negative a half. For part B, y equals a quarter x minus 5. Any line parallel to that must have a gradient of a quarter. And as the gradient times the perpendicular gradient is equal to minus 1, our perpendicular gradient must equal 2. 1 over 4 becomes 4 over 1 and made negative, so we would just have minus 4. In part C, we're not in a position to state the gradient straight away, so we need to rearrange. So taking away 3x from both sides, and divide through by 2, so we have y equals mx plus c. Divide by 2 of each of our terms. Y is equal to negative 3 over 2 x plus 5 over 2. From this situation here, we can say that any gradient which is parallel would be negative 3 over 2. And as m times m perpendicular is equal to minus 1, our perpendicular gradient would be the 3 and the 2 flipped and made negative, so we would have a positive gradient. So the perpendicular gradient of negative 3 over 2 is 2/3. Okay, each time stating the important bit of communication. In 2, given 2 coordinate points, and we need to work out the perpendicular gradient. So we first of all need to work out the gradient of PQ using our gradient formula. So again, x and y for first point, x and y per second. 5 minus 3 is y2 minus y1. And minus 1 minus 4 would be 2 over minus 5. So that's the gradient of PQ. And as MPQ multiplied by its perpendicular gradient is equal to minus 1, our perpendicular gradient must equal 2. The 5 and the 2 flip, and we make negative. Okay, and our third example is again slightly different. A triangle has vertices AOB. Is the triangle right angled at O? You previously could have worked this out using the converse of Pythagoras. We're going to do that this time by using our gradients. Okay, so in this case I want to work out the gradient of OA and be able to work out our value from that, but also work out our gradient of OB. As there. Okay. In both instances, my first point will be the point 0, 0. And I will have x and y of my second point in each. So OA, I have 9 minus 0 over minus 3 minus 0. So 9 over minus 3 gives me a gradient of minus 3. Again, double check that, a sloping line going down from left to right. So happy with the negative gradient. In the second, I have 4 minus 0 over 12 minus 0. 4 over 12, which is equal to 1/3. Okay, so although the triangle doesn't look it, it is in fact right angled. Okay, a wee bit of evidence here. I have MOA multiplied by MOB is equal to minus 3 times by 1/3, which is equal to minus 1. So that's the evidence required. And my communication is as MOA multiplied by MOB is equal to minus 1. What this tells us, the lines OA and OB are perpendicular. That's what my calculation has worked out. Have I answered the question? Is the triangle right angled at O? Therefore, the triangle is right angled at O. So different type of question, but again looking at our gradients. And once again, questions can be found in the PowerPoint. Thank you.